In this video, we're going to start our notes for Table R, which is called the functional group table. So functional groups are exactly what they say. They change the function of the molecule quite a bit, so much so that we even change the name depending on the functional group. So the way you're going to do this, luckily you don't have to memorize anything, but what you do have to be able to do is go to Table R and look at how they named something and then modify the name to name something that is very similar but not exactly the same. So let's look at Table R. So in Table R, my notes, what I did was I used every example of Table R. So the very first problem is the Table R problem. So on Table R, they give you this condensed formula and they name it 2-chloropropane. So we need to figure out why they named it that and then how to use that information to name these two problems, which are very similar but not the exact same thing. So the first thing you've got to do is draw it out. So this one is going to look like this. I'm not going to draw the H's in anymore for these types of problems. It's going to take a little bit too long. So this one is called 2-chloropropane. Let's number it. It does not matter if you number it right to left or left to right, because either way, the chlorine's on carbon 2. So it's the numbering system doesn't really make a difference. And let's figure it out. So what they did was 3 carbons in a row. If it was just this, if I just cover up that, it would be called propane. They then threw 2-chloro in front of it because there was a chlorine on carbon 2. That's it. And if you look at your names, they tell you fluorine, we're going to call it fluoro, chlorine, chloro, bromine, bromo, I for iodo, right? Iodine. So this one, we're just going to call it, notice I'm going to number it this way because the fluorine is what I want. And it's closer to the right side, so I'm going to number it from the right. That way it's on carbon 2. Whereas if I numbered it from the other side, it would be on carbon 3, and I want the lowest possible number. So this thing is going to be called 2-fluoro. Butane, because it's 4 carbons in a row instead of 3. It's that simple. For this, and then condensed, it would be CH3, CH2, CHF, CH3. And I condensed it the same way they condensed the Cl here in the first problem. For the last one, there are 2 groups. There's an F and there's a Cl. So we're going to call it, and again, how we number it doesn't matter because they both happen to be on the middle one. So if I numbered it this way, great. If I number it the other way, it's 2 either way. So this is going to be called 2 2-chloro, 2-fluoropropane condensed. It's going to be looking like this. Now, technically, I don't care if you put the F first or the Cl second. I think since C comes before F alphabetically, then the Cl comes first and the F comes second. I'm not even 100% sure on that myself. And then for these, it's definitely alphabetical in terms of the name chloro and fluoro. If you wrote them 2-fluoro, 2-chloro, I wouldn't take any points off, and I don't think anybody else would either for that matter. So I wouldn't worry about that too much. And again, here's the rules right here, but I got these rules from examining the name. So let's do the next one. What else did I want to mention about these guys? Oh, maybe you've heard of this. It's called a CFC. They're bad for the environment. They were these compounds that we banned back in, I guess, in the 90s and the 2000s. They were responsible for putting that hole in the ozone layer. And so, which is actually starting to fix itself. But by banning these CFCs, we fixed it, right? But CFC actually stands for chlorofluorocarbon. It's these types of molecules. Obviously, we don't really use them too much anymore. in commercial use. They are used in labs for different things, but they're not really used on an industrial scale anymore. All right, alcohols. So here's what they give you on table R. So you're going to look at table R and say, all right, alcohol. This tells me the general formula. This tells me the functional group. So by looking at this, what it's saying is, okay, it's an OH stuck on to an R, R being the carbon. So it's an alcohol group is just an OH that takes the place or that sticks onto a carbon the same way a hydrogen would stick onto a carbon. If we look at the general formula for the halides, they use X because X could be FCl, Br, or I, but it's the same idea. It's a halogen stuck onto a carbon in place of a hydrogen. That's essentially what's happening. So they call it 1-propanol, right? So it would be, if it was just 3 carbons in a row, all single bonds, we would call it propane. They put a 1 on it and then called it an OL because on carbon, well, I guess I'll draw it out for carbon 1. It's going to look like this. On carbon 1, they put an OH group on it. Okay, that's where the name came from. So all you're going to do with these is you're going to drop the E off the alkane name. That's the standard rule for all of table R. You take the alkane name and drop the E off, or you drop part of it. Add OL, I figured that out on table R. I figured out that's what they did. And then you number the OH if necessary. The reason it's necessary is because there's 1-propanol. The OH could be on carbon 2, and then it would be called 2-propanol. There's no such thing as 3-propanol because 3 would just be 1 if I numbered it in the reverse direction. But there is such a thing as 1 and 2. So since 1 and 2 are different, that gets a number. Let's look at the next one. The next one would actually just be called 2-propanol. It's 3 carbons in a row. The OH is on carbon 2. Condensed, it would look like this. Done. And then the last one is just called ethanol, no number. So I want you to think about it for a second and tell me why there's no number. So no number really means that there's no second version. So if I call this carbon 1, then it's 1-ethanol. If I put it on this side, then I would just call this one carbon 1. So then there's no carbon 2. There's no such thing as 2-ethanol. It doesn't exist because I'm going to number either one of these carbons carbon 1 no matter what side the OH is on. So since there's no second version, it doesn't get a number. Condensed looks like this. I'm going to break this video up into several smaller clips so that I do each page separately to make it a little bit easier to follow along with. The next section we're going to do is aldehydes and ketones. So we'll start with aldehydes. And so aldehydes are right here. And if you notice, they would do 3 carbons in a row. So they would call it propane. And then they dropped the E just like normal. And they added AL ending. But if we look at the functional group for an aldehyde, take a look. It is the functional group for an aldehyde is this entire thing right here. So since it has a carbon double bonded to an O and bonded to an H, it cannot go in the middle of a chain. In other words, in order to be in the middle of an extended carbon chain, you're going to need to have a carbon on one side and a carbon on the other, like a ketone. A ketone is somewhere in the middle because R and R is the carbons. This one only has 1 R. So what it's saying is it has to be at the end of the chain. It's never going to be connected because it's got a carbon on it already. It's never going to be connected to, it's never going to be a branch, or at least I should say, in our world, it will never be a branch. And so this is telling us it's going to be at the end of a chain. So since I always know its location, it never needs a number. The key with numbering is you have to know if there's more than one version. And if you can figure out if there's more than one version, then you need a number. If there's only one version of this molecule, then the numbers are unnecessary. It's like being, let's say, you know, you had your own street, right? And you were the only house on the street. Well, you don't need a house number. You're the only house on the street. So like if I won the lottery and I bought my own street and I put one house on it and I said, okay, I'm going to name this house Castle Learning Avenue. And all of a sudden I'm the only house on Castle Learning Avenue. I don't need a house number. I say just deliver it to the house at Castle Learning Avenue. I'm the only one. If I were to get a neighbor, now all of a sudden we need to be numbers 1 and 2. And so now you need numbers to differentiate between which house it is. It's the same way with here. You only with these problems, you only get numbers if there's more than one version. So the one that they named, it was 3 in a row. They added an AL ending. So I'm going to uncondense it. I'm writing this extra H in. Normally it wouldn't be. It would be just left off, just like all the other H's are. I'm writing it in just to make it a little bit more obvious that it's part of the functional group. And I want you to do that as well. So now we're going to name the next two. So think about it. 1, 2, 3, 4, 5. 5 carbons in a row. If these weren't here and it was just 5 carbons in a row, all single bonds, it would be pentane with an E. Since it's a aldehyde, pentanal. Done with the name. No numbers ever. It can only be at the end of a chain. It doesn't matter if it's on the end of this side, because I would call this is carbon 1, or if it's on the end of this side, that's carbon 1. It's on the end no matter what. 4 in a row. It would be butane, B-U-T-A-N-E, butanal. Condensed formula. That's how they condensed it on table R. That's how I want you to condense it. There is another way to condense these. It's much more complicated, and depending on which one came first, the O or the H, it would mean very different things. So don't ever attempt to do that. Condense it the way they do it on table R. Next one. Done. Okay, ketones. So if we look at ketones, they are in the middle of the chain. The way I can tell it is because it's an R and an R. I can also tell from here because they give me 5 in a row, and the double bonded O, which is the functional group, I can tell right here, that's the functional group. It's got to be, it doesn't have to be on the end, but by saying R and R, what it's saying is it has to be in the middle. Because if it were on the end, it's an aldehyde. That's why we're doing these two together. The only difference between an aldehyde and a ketone is in an aldehyde, the double bonded O is at the end of a chain, and in a ketone, the double bonded O is anywhere in the middle of a chain. And if you notice, they give it a number because it can be in different locations. It would be pentane, P-E-N-T-A-N-E. They dropped the E, they added -one. So uncondense it. And it looks like that. So now they're calling it 2-pentanone because the double bonded O is on carbon 2. So now if we do these guys, doesn't matter if I number from the right or the left in this one, because again, the middle carbon would be carbon 3 either way. And then this one, it does matter. Because if I number it this way, it's 2. And then technically, if I numbered it the other way, it would be 3. So it does matter to a point. You'll see in a second. So let's name them. This would be 3-pentanone, and this would be 2-butanone. Or would it? Okay, so that's my question. Is the last one right? And it turns out the last one is not right. And there's a reason. If I put it here, I call it carbon 2. If I put it here, I would just call it also carbon 2. In other words, if I put the double bond O on this carbon, I call it 1,2. If I put it on this double bond, if I put it on this carbon, it's 1,2. That's not a different version. And it can't be on carbon 1s because then it wouldn't be a ketone anymore because it has to be in the middle. So guess what? This one, if you put the number on it, it is wrong. This one is just butanone because there's no such thing as 3-butanone. It doesn't exist. It's just 2-butanone counted from the other side. So be aware of that. And there's your condensed formulas. They shouldn't be too hard at this point. That's it for aldehydes and ketones. Next up are amines and amides, depending on how you say it. Okay, so they have nitrogen in them. So if you notice, both of their functional groups, when we look at them, their names sound similar, and that's actually because they both have nitrogen, so they do have something in common. One thing I need to point out, there is such a thing as what's called a primary, secondary, and tertiary amine. So an amine can have one carbon chain, it can have 2 different carbon chains, because remember, nitrogen can make up to 3 bonds, or it could have 3 different carbon chains. In our world, that will never, ever happen. We are only going to be dealing with primary amines. And so what that means is, while this is all great and all these R's are spectacular, it's good to know, it's our world, an amine is just going to be an NH2 stuck onto a carbon chain, just like an alcohol would be, an OH stuck onto a carbon chain. We're never going to have to deal with harder amines than that. So they have 3 in a row. It would be propane. Since carbon 1 has an NH2, they called it 1-propan amine. All right, that's all they did. So when we uncondense it, it's going to look like this. Common question I get a lot is some people say, well, I'm just going to do this. I'm just going to put it on as an NH2. Could you uncondense the 2 H's on the N? Absolutely. I don't see any real need to. I also think this makes it stand out a little bit more as a functional group. I wouldn't mark it wrong, nor would anybody else. If you had to draw the bonding, then I would draw the H's out. But if you're just, for naming purposes, this is totally fine. I did it here and I did it here again. All right, so that's propanamine. So now this next one would be ethane, A-N-E ending, but it gets an amine ending instead of an E. And then the question is, does it get a number? And the answer is no, it doesn't. Because if I put it on this carbon, I call that carbon 1. If I put it on this carbon, I call that carbon 1. So there's no second version, so it doesn't need a number. Condensed looks like this. Okay, for this next one, now I need a number because it's very large and there's going to be more than one version. So I could put it on carbon 1, and that would be 5 in a row would be pentane. Drop the E, add amine. And since this is on carbon 2, it's 2-pentanamine. But the NH3 could be on carbon 1, in which case it would be 1-pentanamine. It could be on carbon 3, making it 3-pentanamine. You could put it on this carbon. I'm not going to call it carbon 4 anymore, because if it was just on this carbon, I would just number it 1, 2 again. And if I put it on this carbon, I would just call that carbon 1 again. So there are 3 versions of pentane amines. There's carbon 1, carbon 2, carbon 3. Carbon 4 is just a repeat of carbon 2, and carbon 5 is just a repeat of carbon 1. So I like to say, once you've hit the middle mark of the molecule, you've done every version, you've gotten every version possible. And then condensed would look like this. It would look like that. Amides or amides. So amides look like this guy. Again, you can have secondary and tertiary amides, as some people say. We're never going to have that. It's always going to be like this. Double bonded O with an R and an NH2 on it. So the only difference between an amine, a primary amine, and a primary amide is that the amide or amide, depending on who you speak to, there's a double bonded O on the carbon next to the nitrogen. So because of that, we're going to pretend this is an NH2. Think of it like this. So because of the functional group being this guy, essentially, the same way that we knew that aldehydes had to be at the end of the chain because there's a carbon and one R next to it, this is the same thing repeating. So amides have to be at the end. So if you notice, they don't get a number. I'm not going to uncondense the two H's. You can if you want. Okay, so that's what it looks like uncondensed. For this next one, it would be methane, M-E-T-H-A-N-E, but they dropped the E and added amide, methanamide. All right, there's the name, no number needed, because it's only going to be ever a carbon 1, because there's only one carbon in the whole molecule. This is actually an H over here, don't be confused there. So when I condense this one's tricky. The first C does have an H, so I go CH. Then I put the double bonded O, then I put the NH2 on it. Whether or not you put that bond there, that wouldn't make a difference. All right, so that's the condensed version. That one's a little trickier. For this next one, condensing is much more convenient. It's CH3 for this carbon, then CH2, CH2, and here I put a dash in. If you didn't include the dash, that's totally fine. So that's what it looks like. And then this one would be butane, A-N-E, drop the E, add amide. All right, that is amine and amide, or amine and amide, however you say it. And that's it for this page. We've got a few more and we're done. Organic acids are pretty easy. They actually are very similar to both aldehydes and amides, because if you look, an organic acid is a carbon with a double bonded O and an OH on one side, and then it has an R. So just like the aldehyde and just like the amide, right, it is going to have to be at the end of a chain. That's what that's telling me. So therefore, no numbers on organic acids either, which makes things very easy. So 3 in a row, propanoic acid. So what they did was they dropped the E and then they just added oic acid to it. So uncondensing this is going to look like this. Again, I didn't put a bond between the O and the H, but if you put one in between the O and the H, that's totally fine. So for this next one, it's 4 in a row. So butane would be 4. They dropped the E, added oic acid, the condensed version. Oh, it's an OH. Oh, and there's a typo on my notes. That's why I did that. So the typo on my notes, if you didn't find it, there should be an O right there. So I put an OH in. All right. For the next one, 1, 2, 3, 4, 5 carbons in a row would be pentane. We dropped the E and added oic acid. And there it is. Ethers. So ethers are interesting. If you've ever watched like a good spy movie, you've seen that ethers are the thing that the bad guy usually puts on a cloth, and then they cover up the person's face with it, and then the person breathes in the ether, and then they pass out, right? Well, in real life, it would never work like that. You'd have to take 1 or 2 deep breaths of that ether in order to pass out the whole time fighting the person. So, you know, there's a little movie magic going on there. But an ether can do that to you, and it does not take very long, but it definitely takes longer than the movies make it seem. Just because, you know, if you were to hold your breath, think about how long it would take for you to actually pass out from holding your breath. Most people can hold their breath for a minute at least. So you got to worry about that. Now, condensed formula and how they do it. So let's look. This one's actually easy. They're just long. So ethers are, ignore esters. We're doing them last. They're the best, so we save them for last. Here it is. Notice how they named it. They call it methyl. There's a group of 1 on the left. Then they call it ethyl. There's a group of 2 on the right. And the functional group, kind of overshot my highlighter here. Oh, it makes orange again. Is the double bonded O in the middle. So basically an ether is an O in the middle of a chain, and then you just name the chain on the left side you name the chain on the right side, and then you slap the name ether on the end. And that's how you name an ether. So this one's called methyl ethyl ether because there's a group of 1. This is the methyl, and then there's a group of 2. There's the ethyl, and then it's an ether because it has an O between them. So uncondensed looks like this. Done. This next one, they give you the condensed. They want you to draw it. Looks like that. And this would be called 3 in a row, propyl ethyl. Technically, ethyl propyl ether because E comes before P alphabetically, but if you called it propyl ethyl, it'd be totally fine. This next one, it's 2 and 2. So you could call it ethyl ether, or you could get fancy and condense those two and call it diethyl ether. Either one is fine. So that should be CH3, and then a CH2, then an O, CH2, CH3. Last one, this one would be 1, 2, 3, 4. Butyl, 1, 2. Ethyl, ether. That's my butyl. That's my ethyl. And then there's my ether. And there's the condensed version. So that's it for organic acids and ethers. The last one we are going to do for functional groups is going to be esters. Esters they're a little bit harder, so we're doing them last. They have a double bonded O, another O, and it's in the middle of a carbon chain. So you've got a carbon chain to the left of the double bonded O, and then you've got a carbon chain to the right of the double bonded O. So for this one, we're really going to have to draw it out and break down the name on this guy. It tends to be a little difficult. So this is 3 carbons in a row. Then you have, so there's a mistake here. You can't have an O double bonded to another O. That violates the octet rule. So I guess I should have just moved that one over. Okay, so it's going to look like this. So there's my O. Then it's going to have an O and then a CH3. So there is my ether or ester. So it's called methyl because this side only is 1 carbon long. And then this part is the propane, and then they added O8 to it, right? But the reason this side gets the ending is because it's 3 carbons long. So that's what makes it a prop. And then having the double bonded O on that side gives it the O8 ending, okay? So because the prop, the 3 in a row, has the double bonded O, it gets the O8. And then because the other side only doesn't have the double bonded O, it just becomes the YL. That's what's a little bit harder about this. So for this next one, believe it or not, whether you did it, you get it right either way. This one is called ethyl ethanoate. But I want to mention this. This part is the ethyl, and then the ethanoate is this part because of that double bonded O. Okay, so condensed would just look like this. And then for the last one, this 1 carbon has the double bonded O, and then this chain of 3 doesn't. So the chain of 3 gets the YL, the double bonded O, gets the OH. So this is going to be called propyl methanoate, because this gets the OH because of the double bonded O. There we go. And that is everything from Table R. So the thing to remember is you have to be able to take what they give you on Table R. They give you a condensed formula and a name. You're going to want to, if you're having trouble figuring out why it's named the way it is, you are going to want to uncondense it like I've been doing, and then you can break down the name. Figure out why they changed the name from the alkane name, and then they're going to give you something very similar like I've been doing, and then you're just going to have to slightly modify the name to meet the new molecule that's only very mildly different from the one that Table R gave you.